Hello everyone, I'm Ajay Kaja from Mechanical Engineering Department. As engineers, in our projects, we are limited with the tools we have. And in addition to that, we are also limited with the laws of nature and physics. Well, basically Earth's limitations. Now, I want you to imagine what we can manufacture without these limitations. Well, this might seem like an idea far from reality, but it actually isn't. And it's an ongoing project called space manufacturing. Today, I will try to shed a light on this not science fiction, science fact technology, as I talked about two ways space manufacturing can improve technology. I will first talk about material manufacturing opportunities, and then I am going to move on to space system application. Well, let me start by the first one. In 2014, the first ever object produced of Earth in International Space Station by using 3D printing technologies. Since that, many other materials such as filaments, polymers, medical supplies, and even art has been manufactured in space. Space conditions such as the temperature, pressure, convection are completely different from Earth's. Especially microgravity of space is a big factor affecting manufacturing. By using space manufacturing, crystallization of materials can be manipulated into improving their qualities. In space, microgravity lets material grow without encountering walls, and it allows them to mix evenly and hold together without traditional sports. Nearby ultra-high vacuum can help things form without impurities. Another opportunity created by space manufacturing is enhancement of medical supplies. Due to crystal size and their chemical composition caused by space conditions, medical drugs can have different and improved effects compared to the ones produced on Earth. Many companies are already funding space manufacturing researchers to innovate their medicine. Now, let me show you an image which shows the effect clearly, published by NASA in 2015 as a result of Merck researches. This figure shows insulin crystals growing in space and grow on Earth. On the top, you can see crystal produced on Earth, and at the bottom, there are crystal produced in microgravity of space. These examples show the different organization of crystal, and we can clearly see that crystal from space is bigger than those from Earth, which can open a new set of material properties as well as enhance medical efficiency for manufacturing medical supplies. Well, moving on from material manufacturing opportunities, now I'm going to talk about the second way space manufacturing can improve technology, namely application in space. Space manufacturing is a huge step for space exploration researchers. The ability to manufacture in space will change the working system of launching as it reduces the need of launch as well as cost and time of launch, power generation, adjustment, and services. In addition, when there is a need of part exchange in International Space Station, that part can be produced in space and can move with Earth-based remote control, which eventually can reduce up mass and volume for space part in launches. Moreover, in-space robotic manufacturing could also reduce the inherent risks of astronaut spacewalks with robotic arms operating. As another application, space manufacturing can bring brand new possibilities to what we can build in space that is not possible today due to launch restrictions and costs. Assembly of parts are expected to be on orbit, which gives more freedom in designs. An example project aiming to manufacture long baseline telescope that can stretch to 50 meters in space. Now let me show you a video demonstrating the project launched in 2019 as a collaboration of NASA and Made in Space company. This video shows the project OSAM-2. After being deployed into orbit, OSAM-2, short for Orbit Servicing, Assembly and Manufacturing Spacecraft, will 3D print two beams that extend nearly 10 meters from either side of the spacecraft, as you can see. Solar arrays that are rolled will extend outward from the spacecraft affixed to the end of each beam as they grow from the 3D printing process. In the end, 3D printed solar arrays will be able to generate up to 5 times more power than traditional solar panels. These animations show that space manufacturing is an important process in producing space systems that are not possible in today. Well, summing up, in this presentation, I talked about two ways space manufacturing can improve technology, namely material manufacturing opportunities and space applications. Looking at current projects and future plans in space manufacturing, we can predict that space manufacturing is going to be a big part of technology and will open new realm of innovation for projects to come. Well, thank you for listening. If you have any questions, don't hesitate to send them to me. And here's my reference list.